Okay, so now we're going to take a look at Unit 8, Lesson 3, Day 2 homework. And this one has been completed after the second set of 831 done in class. And we're going to look first starting at problem number 4, and then we'll do problem number 5, which deals with an application of the sine wave. So this is on page 590 in the Course 3 textbook of Core Plus Mathematics. So I'm taking a look at question number 4. And it says to use algebraic reasoning and the inverse sine function to find all solutions in radians for the following equations. Give exact solutions if possible. Two big things to note here. We're going to use solutions in radians, so I do not want to be in degree mode if I'm using my calculator. I also want to note the fact that it said to find all solutions, so I know that using inverse sine will give me one solution. I'm going to have to make sure that I find the second solution in the same period, as well as indicate all of the possible solutions for any period. So that could be a little bit more work. And the last part of them, giving exact solutions if possible. So I'm going to look out for those ratios dealing with a half and square root of 3 over 2 and square root of 2 over 2, the ones that come from the special triangles we've discussed in class. So let's get started. I'll start here by writing 4a. 4a says the sine of, it says 2 sine of x plus the square root of 3. Ding, 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 bell should go off. Square root of 3 is going to be one of those special ratios. So here's the setup. And so the first thing I want to do is to try to get x isolated. So I want to get rid of this 2. So in the square root of 3 to the other side. So let's start with getting the square root of 3 to the other side. Subtracting the square root of 3. So this will leave me to sine of x equals the square root of 3. To get sine of x by itself, we'll divide by 2 on both sides. Therefore, the sine of x is equivalent to the square root of 3 over 2. This is an indicator that I have a special right triangle, so I'll do a quick sketch again of my right triangle that I know has this ratio. Knowing that square root of 3 over 2 exists, this was telling me that the square root of 3 is like having the opposite side to x, and the 2 would be the hypotenuse. So I'll run 2 as the hypotenuse, and I know that if the hypotenuse is 2 and this is a special triangle, the short side is 1, and that makes this side the square root of 3. So x is going to be this angle currently, which happens to be on a 30, 60, 90, the 60 degree angle. So when I get to this answer, I can then say that x is equivalent to 60 degrees. All right, now last homework session I mentioned how you can verify that using your calculator too. If I use the inverse sine of square root of 3 over 2 and I'm in degree mode, I'll actually get out a nice degree value. So let's just take a look at that real quick too. I'm currently in degree mode. You can tell from my last session that this is still up at 30. So I'm going to go ahead and type in the inverse sine of the square root of 3, divide that by 2. And sure enough, I get 60 degrees out. Okay. Now if I was in radian mode, I wouldn't get this nice number, right? I would get out a decimal that repeats because pi, of course, is an irrational number and it doesn't end or has no repeating decimals that we can write as a fraction. So I can either take this answer and convert it to radians at this point in time, or I can go to the decimal approximations. Since this question is asking for exact, let's leave it exact. I know now that this is 60 degrees, or equivalently, I know that that's pi over 3 radians. I know that too because I can convert this, right? Converting to radians means I could divide by 180 and throw on a pi here, which is divided by 180 and multiplying by pi mathematically. 60 divided by 180 is 1/3, so that's why we get pi over 3. So that's the first solution, right? But we need more solutions. We actually need the second solution in the same cycle as well as the infinite number of solutions that follow. So the first thing I'm going to do is, for this answer, is actually tap on the fact that this is pi over 3 radians. I'm going to now say that one of my solutions is pi over 3 plus 2 pi n, where n is an integer. That's one way to write out my full solution. Okay, n is an integer. What that's saying is that n can be any counting number, 1, 2, 3, 4, 5, 0, and the negatives of those numbers. Well, I also like to think of n as being the next cycle. So 2 pi we know is a period of one full cycle of sine. N would be the next full cycle, and the next full cycle, and the next full cycle. So the first solution, pi over 3, is great. If I want the next solution that's a whole cycle later, I'd put n as 1. That's the first cycle after the original one. Or the 2 here or 3 here would imply all of those pi over 3 values in the next cycles. Okay. The next thing I want to do is figure out the other one that's in the same cycle. I'm going to do a quick sketch for a moment here. to remember that the sine function starts off at its midline, goes to maximum, down to minimum. We're looking at square root of 3 over 2. We know it's a little higher up. That's about here. I'm looking for this solution now. So I'm going to use this symmetry of the sine curve to remember that these distances are equivalent to each other. And at this point right there, that's at pi. So if the distance is pi over 3 and this is pi, this solution would have to be pi minus pi over 3. So pi minus pi over 3, if I put a common denominator here, this would be 3 pi over 3 minus pi over 3. This simplifies down to 2 pi over 3, which yields my second solution. If I want the solutions that correspond to that, I have to add 2 pi n, where n is an integer. And there's the solution for part A. Let's take a look now at part B. Part B reads the sine of 3x equals 1/2. Again, I can't get to the 3x yet. Whoops, I actually copied down the same thing from 3b. So I'll modify this. Okay, a little pen scratch out there. This actually is going to be 4 sine of x plus 3 equals 1. So we'll take this answer and start by subtracting 3. Then 4 sine of x is equivalent to a negative 2. Then we will divide by 4. This yields that the sine of x is equivalent to a negative 1/2. Ooh, a half, it's coming up again, right? So a half goes back to our right triangle. That 1/2 would be a ratio of the short side to the hypotenuse. You're now dealing with a 30-degree angle, but in radians, we would say this is equivalent to the pi over 6 value. Note the negative, though, right? If you think about the graph for this up here, we're going to go negative this time, right? And the negative value of this puts us down in this direction. Negative 0.5 puts us down here. All right, so the solution that comes out of this is that x is equivalent to a negative pi over 6. Okay? Now, if I kept going with that idea, that means another possible solution would be the one down here. Okay? And the one over there, the second one I just labeled would be a full 2 pi after that piece. So the second answer I can get to this, again, will be the pi minus a negative pi over 6, which would yield, if I make this 6 pi over 6 minus a pi over 6, this is going to yield, oops, minus a negative, I should say, which makes a plus sign, 7 pi over 6. All right, now both of these solutions are on the right track. We need to write the infinite pieces. So my one solution was a negative pi over 6, and we'll add 2 pi n. And we should also include then that x could be 7 pi over 6 plus 2 pi n. And we have to include that n is an integer. Now, this is a great answer right here. Nothing wrong with this. Note how I went with one that was negative and one that was positive right there. I can do that. An alternative way is to write the other one that's negative here too. It just doesn't matter. They're both the same set of solutions. So for convenience, I'm going to leave the answer as it is for part B. Let's go to part C. Part C will read 3 minus the sine of x equals 2 sine x. Okay? Slightly different problem. In this case, we have sine on both sides. So I'd like to combine the sines to one side. So we'll start by adding this sine to this side and adding this sine to this side. So what I have now is that 3 is equivalent to 2 sine x plus 1 sine x would be 3 sine of x. Then dividing by 3, both sides will yield 1 equals the sine of x. So at this point in time, I just need to take the inverse sine of 1. Now, don't mind that bell. I'm working at school today, so you're hearing a bell. So this right here, sine of x is equivalent to 1. I can look at a couple different ways. I'm actually going to go back to the idea of a unit circle. On a unit circle, the radius is 1. So it referenced the fact that this hits the axes at 1, 0, and this is at 0, 1, of course, and this is negative 1, 0, 0, negative 1. Sine references y values, so it's the full height above the x-axis here on the y. This is a value of 1. So when I get to that level, the angle that I've rotated to get there is a 90-degree angle, or pi over 2. So when I do this answer, I know my answer is going to be x is equivalent to pi over 2. But if I hadn't referenced this, you might have said, well, I can easily do the inverse sine of 1, and that's what equals x. Let's just see what that looks like on our calculator for a moment. Okay, the inverse sine of 1 Here I'm still in degree mode, as you see, is 90 degrees. I could then convert that to radians. Let's switch back over to the radian mode just to see what it would show up as. Okay, and this time I'm going to make radians the default mode. And now if I try that again, I'm just going to hit the second enter button. Now I get 1.5708. That 1.57, you're going to want to know that number. That's one that will pop up quite often in this class and beyond. So 1.57 is referenced as pi over 2, approximately. So we know our answer in radians is pi over 2. So that's one possible solution, right? So I can write out the full answer by saying pi over 2 plus 2 pi n, where n is an integer. Now we have to ask, is there a second one? What happens if I do pi over 2 subtracted from pi? Let's try it. Pi minus pi over 2. I've put that in common denominators. 2 pi over 2 minus pi over 2. That's equivalent to, well, 1 pi over 2. It's the same thing, right? Well, essentially what you're doing is, because you're at the top of the circle, 2 pi later gets you to the top of the circle again. This answer of y being equivalent to 1 only intersects the circle one time. So it only has one solution in every cycle. So we do not have a second expression, just one this time, pi over 2 plus 2 pi n, where n is an integer. And that ends question number 4.